Welcome to Deep Dive Learning by HaleForm. This is episode 5, titled S3D Piping Part 3.
Hello.
Today, we're taking a really focused look at Intergraph Smart 3D piping.
Yep, specifically how you work with, well, the fundamental building blocks of your models, components and taps.
Right, the essential bits.
Exactly. Think of this as getting to grips with the essential nuts and bolts of smart 3D piping. Our aim today is to give you a clear understanding of adding, editing, and managing these key elements.
And we're drawing from your experience at HaleForm Technology Solutions, right?
That's the plan. We want to equip you with practical knowledge, without bogging you down in tons of unnecessary detail.
Perfect. Okay, so let's dive straight into components then. When we talk about components in smart 3D piping, what exactly are we referring to in the model?
Basically, components are all the physical items that actually make up your piping system.
Like the hardware.
Precisely. We're talking about things like valves, for controlling flow, steam traps for condensate, strainers to catch debris, and all the various fittings.
Tees, elbows, that kind of thing.
Right. Tees for branching, turns for changing direction. It also covers safety items, maybe fire protection components, and even piping specialties.
Okay.
And interestingly, it also includes surface-mounted components. Think like ultrasonic flow meters. These are a bit different because they attach to the pipe surface. They don't actually break the pipe run itself.
Ah, okay. So they sit on top, essentially.
Yeah. Unlike an inline valve, which sits in the pipe.
Got it.
Yeah.
So you've got this whole library of parts. How do you actually get them into your 3D model? What's the starting point?
Well, the main entry point for adding pretty much any component is the insert component command. You'll usually find that on the vertical toolbar.
Okay.
Now, if you're adding a component onto a pipe that already exists, Smart 3D is actually pretty smart about it.
How so?
It recognizes you're putting something in the line, so it automatically splits the pipe right where you choose to insert it.
Oh, that's handy.
Yeah, and depending on your project specs, it might even automatically add the necessary mating components too, like flanges or gaskets to make sure you get a proper connection. Saves a lot of clicks.
Definitely sounds like it saves time. Could you maybe walk us through the basic steps for putting a component onto an existing pipe?
Sure thing. So after you click that Insert Component command, your next move is to select the pipe itself, the one you want the component on.
Okay.
You might see these little markers pop up on the pipe as you hover over it. Those are called Divisor Point glyphs.
Divisor points, what do they do?
They let you easily snap to predefined spots along the pipe, like the exact midpoint or maybe thirds or quarters. It makes placement really precise.
Can you change how many points show up?
You can, actually. That setting is tucked away in the SmartSketch 3D settings. Under Tools, then Options, you can set the number of divisor points there.
Good to know. Okay, so you pick your spot using a glyph or just clicking. Then what?
Then you choose the specific type of component you want, say a gate valve, and then the particular option, which is usually the size or pressure class from your spec.
Right.
After that, you'll use the tools that appear, usually on a ribbon bar, to fine-tune its position. You've got commands like flip to change its orientation back to front.
Okay, like turning the handle direction.
Exactly. Or reference position to align it with some other geometry, and angle to set its rotation precisely. Once you're happy, you just click Finish. Component placed.
What if you need to add a component, but maybe it's not directly on a pipe that's already there, like maybe you're starting a brand new line or just placing something in open space?
You'd still start with the Insert Component command, but instead of selecting a pipe first, you'd just click directly in the graphic view where you want the component to roughly go.
Okay.
Doing that usually brings up the new pipe run dialog box. That lets you define the properties for the new pipe run that this component will belong to.
Or you could pick an existing run first.
Yes, alternatively, you could pre-select an existing pipe run from the run box on the ribbon before clicking in the view. Then the software knows which run the new component belongs to.
Makes sense. And positioning it.
It's similar. Once you've dealt with the pipe run, you select your component type and option. Then you use tools like reference position, axis of rotation, rotate, and angle to get it oriented just right in that 3D space before you click Finish.
And can you start routing right away from that component?
You bet. What's really useful is that as soon as you finish placing a component like that, you can immediately click on one of its open connection points and start routing pipe using either the wet pipe command or maybe the quick route command.
Nice, seamless workflow.
Very much so. It's that kind of flexibility that, experienced teams like the ones at HaleForm Technology Solutions really leverage to build out complex piping systems efficiently.
I can see that. What about curved pipes? Is putting a component on a curved section any different?
Nope, the process for curved pipes really just mirrors what you do for straight ones.
Oh, really?
Yeah, you hit Insert Component command, then you just select the curved pipe itself. Again, the software uses your click point or maybe a divisor point if one's visible on the curve as the insertion location.
And then same steps. Choose type, option, adjust position.
Exactly. Select type, option, tweak the positioning if needed, click finish. The main thing is just selecting the curved pipe as your target initially.
Sounds straightforward. It seems like there are multiple ways to approach this depending on what you're doing. What if you're like right in the middle of routing a pipe with the root pipe command and you realize, oops, I need a valve right here.
Yeah.
Do you have to stop everything?
Not at all. That's another smooth integration. While you're actively routing, you can just click the Insert Component command on the toolbar.
While the routing command is still active.
Yep. You then choose your component type and option, position it where you need it along the route you've laid out so far, and hit finish.
And what happens to the routing?
Smart 3D automatically pauses the routing, places the component right there, and then immediately lets you continue routing from the other end of the component you just placed.
Wow, that is efficient. No breaking the flow.
Exactly. One little thing to be mindful of, though, if you're inserting a component right at the end feature of an arc pipe segment you just routed,
Okay.
you'll see options on the ribbon like arc routing or straight routing. You need to choose which one you want before placing the component, because that determines whether the next piece of pipe continues as a curve or starts as a straight segment. It affects the downstream geometry.
Ah, important detail for maintaining the design intent. Got it. Now, I also heard you can place components using their specific tag name.
That's correct. Very useful for large projects or when working closely with PIDs.
How does that work?
You'd use the Insert Component command again. Then you select your target, could be a pipe, an existing end connection, or even a nozzle on equipment. Then, in the type list where you normally pick valve or T, you scroll down and select the option that says Specify Component Tag.
Ah, special option.
Right. That opens up a dialog box. From there, you can browse or search through your project's database for the specific tag name of the component you want to place.
So you find the tag like XV101 or whatever.
Exactly. You select the tag, click OK, and then back on the main command, you just hit Finish. Smart 3D looks up that tag, finds the corresponding component definition, and places it for you.
That sounds great for placing instruments, maybe.
It's particularly useful for instruments, yes. And just like placing regular components, you can still use those divisor points on the pipe or nozzle you selected for really precise positioning of that tagged item.
Makes sense. Connecting the 3D model directly to the tag data is crucial.
Absolutely. And HaleForm Technology Solutions, with their deep expertise in data management, PID conversions, they really understand the critical importance of accurate and consistent tagging throughout a project lifecycle.
All right, all ties together. Okay, what about a specific scenario? Inserting a component into a pipe that's defined as a purchase length, like a pre-cut spool piece. Any special steps?
Yes, there are a couple of things to keep in mind there. First, you select the straight pipe segment, that's your purchase length.
Oh?
Then you choose your component type and option like usual. Now here's a key step. You usually need to select a female reference port on the component for placement onto the purchase length.
Why female?
It generally relates to how the connections are defined and how the split works. Also, critically, you need to make sure that inserting this component won't violate any minimum pipe length rules that might be set up in your project specifications for purchase lengths.
Ah, so it won't create tiny, unusable leftover pieces.
Exactly. You can adjust the component's position, but only within the limits allowed by those rules and the existing pipe length. Once you click Finish, Smart 3D splits the original purchase length pipe into two separate segments.
So the original single piece is gone.
It's replaced by the component and two new pipe pieces on either side. Because of that, you'll almost certainly need to go back and manually respecify the appropriate lengths for these two new pipe stocks to reflect the reality of the cut.
Okay, so there's a follow-up step required there. Good to know. We've covered standard fittings. What about inserting more specialized things, like maybe inline instruments or specific piping specialty items? Is that different?
The basic process is very similar. You still use the Insert Component command.
Okay.
For inserting an instrument, you'd select your target point pipe, end, nozzle, whatever. Then in the type list, instead of a standard component, you choose Browse Custom Instruments.
Ah, another browse option.
Right. This opens a selection dialog. You can either pick from the full catalog of available instruments by clicking the More option, or you might see a list of instruments you've recently placed in the model, which is handy for repetition.
Specialties, like expansion joints or something.
Same idea. You select your insertion point, but this time in the type list, you choose Browse Piping Custom Specialties. Again, you'll get a dialog to pick from the catalog more, or recently used items.
So the workflow is consistent, just pointing to different parts of the catalog.
Precisely.
You mentioned those surface-mounted components earlier, like the ultrasonic meters. Can you elaborate a bit more on how you insert those?
Sure. For those, you select the pipe you want to attach it to. Then, from the available list, you choose the specific shortcode and the option for that surface-mounted component.
Shortcode, like an identifier.
Yeah, it's how they're often defined in the catalog. Once selected, you adjust its position along the pipe's surface, get it where you want it, and then click Finish.
Seems simple enough.
It is, but there's a really important prerequisite here.
Oh, what's that?
Before you can successfully insert any surface-mounted components in your project, the necessary sample data for surface-mounted components must have been bulk loaded into your project's reference data.
Bulk loaded. How?
Usually using a specially formatted Excel workbook, often called PCF.XLs or something similar, you have to populate the catalog with these definitions first. They aren't always standard out of the box.
Ah, okay. So some setup is required beforehand.
Definitely. And that's actually an area where, the catalog customization team at HaleForm Technology Solutions has a ton of experience setting up these kinds of specialized component catalogs and ensuring the data is loaded correctly.
Good to know who to call if you run into trouble there. Okay, Smart 3D also seems to have these shortcuts for inserting default things, default branches, turns, reducers. How do they work?
These default options are super handy. They let you quickly place common fittings based entirely on the rules defined in your project's piping specification.
So it takes the guesswork out.
Pretty much. For a default branch, you just select the point on the main pipe where you want the branch to come off. Then, in the type box of the Insert Component command, you choose Default Branch. You'll then need to define the pipe run for the branch itself. Are you starting a new run from this branch or connecting to an existing one?
Right. Specify where it's going.
Exactly. Once you do that, Smart 3D looks at your selection point, the sizes involved, and consults the branch table within your piping spec to automatically determine and place the correct fitting like a T or maybe a weldolet.
Clever. And default turns and reducers. Similar logic.
Very similar. For a default turn, you select the insertion point, typically an open end, and choose Default Turn from the type box. The software just uses the spec to figure out the standard bend radius or fitting type, like a long radius elbow.
And reducers.
Same start. Select insertion point, choose Default Reducer. Because it's reducing, you'll also need to specify the pipe 1 properties for the other side, the smaller or larger side you're connecting to. The software then picks the correct reducer, concentric or eccentric, based on the size change defined in the spec.
Using the spec rules really streamlines things. What if you need to put a branch connection directly onto another component, say adding a small drain valve onto the body of a larger valve?
You can do that. You'd first select the base component, your larger valve in this example.
Okay.
Then usually on the ribbon, you'd indicate which pipe run this new branch should be associated with. After that, you use the Insert Component command again.
And choose the drain valve type.
Right. You choose the specific type of branch component you need, like your small valve. You might then need to specify a distance and maybe pick a reference port on the main valve body to precisely locate where that drain connection goes.
What about orientation?
Good point. For some connections, especially things like lateral branches, lateral lets, or connections onto end features, you'll use the component orientation options to make sure it's angled correctly.
Now, you mentioned taps earlier. Is there a link here?
Yes, absolutely. This is crucial. When you route a pipe from a branch fitting that you place directly onto another component like this, Smart 3D automatically creates a tap on that original component right at the connection point. It understands that's the attachment point.
Ah, so the tap is generated automatically in that case.
Correct. And the flip side is also true. If you later delete that branch fitting you placed, the associated tap on the parent component gets deleted automatically too. They're linked.
Interesting relationship.
It maintains model integrity. And actually, the programmers at HaleForm Technology Solutions often work on customizing related things like hangers and supports, which frequently need to interface correctly with these kinds of branch connections and taps.
Makes sense. Okay, what about elbowlets? They seem a bit unique. How do you place those?
Yeah, elbowlets are a bit of a special case. It's typically a two-step process.
2 steps?
Yep. First, you need to place a tap directly onto the elbow where you want the elbolet. So you use the Insert Tap command, select the elbow.
Okay, insert a tap first.
Right. And when you define that tap, you need to make sure the tap size you select matches the primary connection size of the elbolet you intend to place. You finish placing the tap.
Then step 2.
Step 2 is you use the regular Insert Component command. You select the tap you just created as your insertion point. Then in the type list, you choose elbolet, select the right option, and click Finish. It attaches the elbolet fitting to the tap.
Got it. Tap first, then component onto the tap. Finally, for component insertion, how do you handle creating a specification break at a reducing component? So where both the pipe size and the piping spec change.
Right, a common scenario. The cleanest way to manage this is usually like this. First, place a standard flange on the end of your initial pipe run. Make sure this flange matches the spec and pressure class of that first run.
Okay, flange on the end of run 1.
Then, starting from the open end of that flange, you begin routing your second pipe run. Crucially, when you define the second run, you assign the new, different piping specification to it.
So the second run has the different spec from the start.
Exactly. Now, the last step is you go back and select the original flange you placed at the end of the first run.
The one connecting the 2 runs.
Yes. You select it, go into its properties, and change its type from a standard flange to a reducing flange. You'll then specify the size change required.
Ah, so you convert the standard flange into the reducer after connecting the second spec run.
Precisely. This clearly marks the spec breakpoint and incorporates the size reduction all in one fitting, maintaining the connection between the 2 specifications.
That makes logical sense.
It's a robust way to handle it. And again, this touches on specifications. HaleForm Technology Solutions can definitely provide expert consultation on piping specification setup and customization to ensure these kinds of transitions are defined and handled correctly within your Smart 3D projects.
Okay, wow, that was an incredibly thorough overview of adding components. Now let's switch gears slightly. What about editing them? Once a component's in the model, how do you make changes?
Right. Editing is just as important. It's a constant part of the design process, isn't it?
Always tweaking things.
Exactly. Well, even before you fully finalize placing a component using the Insert Component command, you can actually click the Properties button, usually on the ribbon.
Before hitting Finish.
Yeah. This lets you review and potentially change the component's type or option or other settings before it's actually committed to the model, kind of a final check.
Okay. And after it's placed.
Once it's in the model, you first need to select it. You can use the standard select command and maybe use the filter to only select piping features, which makes grabbing components easier in a busy model.
Good tip.
Once selected, you can either go up to the main menu, usually Edit Properties, or just click that same Properties button on the ribbon again.
And that opens a dialog.
Yep, it opens a Properties dialog box where you can modify various attributes of that component, maybe change its spec, its tag, description, things like that.
Can you change rotation from there too?
You often can. For more dynamic adjustments, though, you might just use the Rotate option directly on the ribbon after selecting the component. Or, like you said, within the Properties dialog, there's usually an angle box where you can type in a very specific rotation value if needed.
Okay. You mentioned different component types earlier. Are there any special things to know when editing, say, reducers?
Yes, reducers have a couple of quirks. You'd select the reducer or maybe a pair of concentric reducers if they were placed together and then access its properties. From there, you could change the type option if needed, maybe switch between concentric and eccentric if allowed by the spec.
What about rotation?
For rotation, especially with concentric reducer pairs that are often used to maintain centerline elevation.
Right, keeping the pipes aligned.
There's an interesting master-slave relationship. The first reducer you select in the pair becomes the master. If you then rotate that master reducer using its angle property,
Okay.
the angle of the second slave reducer automatically adjusts itself to maintain a 0 offset between them. It keeps them perfectly aligned.
Ah, clever. But you can't rotate multiple separate reducers at once.
Correct. If you select several independent reducers in different locations, you generally can't modify the rotation angles simultaneously through the properties box. You'd have to do them one by one or use the rotate command.
Got it. And what about just physically moving or rotating components already sitting in the model?
Pretty straightforward. To move something, you select it, then click the Move To command on the ribbon.
And then click the new spot.
Basically. You'll be prompted to specify the new location. You can graphically pick a point in the model, snap to something, or even type in coordinates. For really precise moves, there are helper tools you can use beforehand, like Tools Point Along command to define a point along an edge, or Tools Pinpoint command to set up really specific offset targets.
Okay, and rotating.
Similar process. Select the component, click the Rotate command. Then you can either just interactively drag your mouse around to visually set the new orientation, or you can type a specific angle value into the input box that appears on the ribbon.
What about rotating something connected to a nozzle, like a valve bolted to equipment? That seems tricky.
It can be slightly more involved. The key is usually to select the end feature of the component that is not the nozzle connection, so the other end of the valve.
Select the free end.
Right. Then you typically need to lock the plane of rotation so it's perpendicular to the nozzle axis, and you might also need to lock the length of any pipe attached to that free end so it doesn't stretch or shrink.
Okay, lock plane and link.
Once you've locked those, you can then often use the Move To command, snapping to points around the nozzle axis, to effectively rotate the component around the nozzle connection accurately.
A few more steps there, but makes sense for control. And finally, the simple one, just deleting a component.
Dead simple. Select the component using the Select command, and then just hit the Delete button on the toolbar, or press the Delete key on your keyboard.
And does it take care of connected bits?
It does, and this is very helpful. Smart 3D automatically finds and deletes any mating components that were originally placed with the component you're deleting. So if you delete a flanged valve, the associated flanges and gaskets on both ends usually get deleted automatically too.
Oh, nice cleanup. Prevents orphan parts.
Exactly. Keeps the model tidy.
All right, excellent. Let's shift gears one last time now and talk about taps. We mentioned them briefly. What exactly is the main purpose of a tap in Smart 3D piping?
So in Smart 3D, a tap is essentially a connection point. You can add taps to the vast majority of your piping components. Pipes, elbows, tees, valves, most things really.
But not everything.
The main exceptions are mating parts, like the actual sealing faces of flanges. You wouldn't put a tap right on the gasket surface, for example.
Makes sense. And what are they used for?
Primarily, taps are used to create connections for things like drain lines, vent lines, or for attaching various kinds of instruments directly onto your main piping components. Think pressure gauges, thermowells, sample points.
Okay, those essential small connections. So how do you actually insert a tap onto a component?
The process starts with the Insert Tap command, which, like the component command, is usually found on that vertical toolbar.
Got it. Insert tap.
First step after clicking that is to select the specific component you want to place the tap on.
Like clicking the body of a valve or a section of pipe.
Exactly. Then, in the option box that appears on the ribbon, you'll choose the desired tap identification or size from the list defined in your project's reference data.
Okay, pick the size, like 1/2 inch NPT or something.
Right. You also have the option to select a reference position on the component surface and then maybe specify a precise distance from that reference to locate the tap. You can also rotate the tap if needed to get the orientation right before you finalize it by clicking Finish.
Can you attach a fitting directly onto a tap you've just placed? Like putting a small valve onto that instrument tap?
Yes, absolutely. That's a common workflow. You'd first select the tap itself, the one you just placed.
Select the tap.
Then you click the Insert Component command. Now, on the ribbon in the Run box, you'd typically select New Pipe Run because this little connection is often its own small run.
Okay, starting a new mini run.
Right. Then, in the Type drop-down list, you just choose the specific branch component you want to attach your small valve, for instance. Smart 3D will automatically position that valve right at the location of the tap you selected.
And does this also create that automatic link you mentioned before?
It does. Just like placing a branch fitting directly on a main component, routing a pipe from a tap like this automatically generates the necessary branch fitting, like a nipple or coupling, at the tap location. And again, if you delete the tap later, any fitting connected directly to it will also be deleted.
That consistency is good.
It really helps maintain the relationships in the model. And actually, managing these kinds of interconnected elements and ensuring data consistency across runs and components is something the Smart 3D administrators at HaleForm Technology Solutions are highly skilled at handling within large, complex piping models.
I can imagine that's crucial. What if you need to adjust a tap after it's placed? Can you move it or rotate it easily?
You can. To move a tap, you just select it. Then, usually in the Properties pane or perhaps directly on the ribbon, you'll find input boxes where you can type in new values for its distance along the parent component, its orientation around the circumference, or its rotational angle.
So you can nudge it numerically.
Exactly. And similarly, to rotate a tap, you select it, click the Rotate command, and then you can either drag your mouse to visually adjust the angle or type in a specific rotation value.
Okay. And what about editing other properties of the tap, like its permission group or approval status?
Good question. You would select the tap and then go to Edit Properties, just like with a regular component. However, there's a really key point to understand about tap properties.
What's that?
You cannot directly modify the permission group, PG, or the approval state, AS, for a tap itself within its own properties dialog.
No, why not? Where does it get those from?
Those critical properties, PG and AS, are automatically inherited directly from the parent component that the tap is attached to.
So the tap is on an elbow, it gets the elbow status.
Exactly. If the elbow is approved and in the piping permission group, the tap automatically has those same settings. You can't change the tap's status independently.
What if you want the tap to match the status of the pipe run it's associated with, not necessarily the component it's sitting on?
That's a common requirement. There's a way to do that. You can right-click on the pipe run itself in the Workspace Explorer, and there should be an option like Select Nested.
Select Nested.
Choosing that will select the pipe run and all the components and taps that are directly associated with that run. Once they're all selected together, you can then apply the desired permission group and approval state, and it will propagate down to the selected taps as well, overriding the inheritance from the parent component just for those properties.
Oh, okay. So you manage it via the run using Select Nested.
Correct. It ensures consistency and data integrity for the whole line, which, as you can imagine, is a core principle in how HaleForm Technology Solutions approaches managing data in both Smart PID and Smart 3D projects. They focus on that data flow.
Right, maintaining that single source of truth. Okay, and finally, just deleting a tab.
As simple as deleting a component. Select the tap, click the Delete button on the toolbar, gone.
Okay, brilliant. Let's maybe take a step back and unpack what we've covered in this pretty deep dive into components and taps in Intergraph Smart 3D piping.
We've covered quite a bit.
Yeah. You listening should now have, hopefully, a much clearer understanding of the different ways you can add these fundamental elements, how you can make edits when needed, and also the specifics around working with taps to create those crucial drain, vent, or instrument connections.
And here's where I think it gets really interesting. When you start to consider the level of precision and just the sheer variety of options Smart 3D gives you for managing even these seemingly simple things like components and taps, you really begin to appreciate the power and the flexibility that's built into this software. It's all geared towards creating really accurate, really intelligent piping designs. Mastering these component and tap functionalities is genuinely key to streamlining your workflows and ultimately minimizing potential errors down the line in your projects.
So thinking about what this all means for you, the listener, hopefully this deep dive has armed you with some valuable, immediately useful knowledge for your work in Smart 3D piping.
Would hope so.
And remember, companies like HaleForm Technology Solutions, with their deep expertise across the board, Smart PID, comprehensive Smart 3D administration services, their real knack for catalog and specification customization. They really are a leading resource ready to support you with your Smart 3D needs.
Absolutely. If you need help implementing this stuff or managing your projects, they're the people to talk to.
You can easily reach out to them. Their contact is business.development@haleform.com.
And all this discussion kind of raises an important question for you to ponder. How might a more thorough, a deeper understanding of Smart 3D's component and tap features all these little details we talked about? How might that empower you to tackle more complex piping design challenges?
Yeah, what new possibilities could it unlock?
Exactly. Think about the potential efficiency gains or maybe the ability to create even more intricate, more optimized designs because you really understand how to manipulate these core elements effectively.
That's a great thought. And for those of you who want to dig even deeper, we definitely encourage you to get hands-on, explore the specific options, the settings within each of these commands we discussed today, right there in your own Smart 3D environment.
Yeah, nothing beats actually trying it out for yourself. Click the button, see what happens.
Absolutely.
Well, thank you all for joining us for this deep dive session. We really trust that this has been a valuable shortcut to becoming more well-informed about the ins and outs of working with components and taps in Smart 3D piping.